CIET NCERT presents audiobook Ganit Prakash, Textbook of Mathematics for Grade 7.
Chapter number 2, Arithmetic Expressions. Page number 24. The right side of the page has a QR code. By scanning the same, you can reach out to the additional resources. 2.1 Simple Expressions. You may have seen mathematical phrases like 13 plus 2, 20 minus 4, 12 into 5 and 18 divided by 3. Such phrases are called arithmetic expressions. Every arithmetic expression has a value which is the number it evaluates to. For example, the value of the expression 13 plus 2 is 15. This expression can be read as 13 plus 2 or the sum of 13 and 2. We use the equality sign equal to denote the relationship between an arithmetic expression and its value. For example, 13 plus 2 is equal to 15. Example 1. Mallika spends 25 rupees every day for lunch at school. Write the expression for the total amount she spends on lunch in a week from Monday to Friday. The expression for the total amount is 5 into 25. 5 into 25 is 5 times 25 or the product of 5 and 25. Different expressions can have the same value. Here are multiple ways to express the number 12 using two numbers and any of the four operations plus, minus, multiply and divide. 10 plus 2, 15 minus 3, 3 into 4, 24 divided by 2. Choose your favorite number and write as many expressions as you can having that value. Comparing expressions. As we compare numbers using equal to sign, less than and greater than signs, we can also compare expressions. We compare expressions based on their values and write the equal to, greater than or less than sign accordingly. For example, 10 plus 2 is greater than 7 plus 1. Page number 25. Because the value of 10 plus 2 is equal to 12 is greater than the value of 7 plus 1 is equal to 8. Similarly, 13 minus 2 is less than 4 into 3. Figure it out. Question number 1. Fill in the blanks to make the expressions equal on both sides of equal to sign. A. 13 plus 4 is equal to dash plus 6. B. 22 plus dash is equal to 6 into 5. C. 8 into dash is equal to 64 divided by 2. D. 34 minus dash is equal to 25. Question number 2. Arrange the following expressions in ascending, that is increasing order, of their values. A. 67 minus 19. B. 67 minus 20. C. 35 plus 25. D. 5 into 11. E. 120 divided by 3. Example 2. Which is greater? 1023 plus 125 or 1022 plus 128? Imagining a situation could help us answer this without finding the values. Raja had 1023 marbles and got 125 more today. Now he has 1023 plus 125 marbles. Joy had 1022 marbles and got 128 more today. Now he has 1022 plus 128 marbles. Who has more? This situation can be represented as given in the picture on the right. To begin with, Raja had one more marble than Joy. But Joy got 3 more marbles than Raja today. We can observe that Joy has 2 more marbles than Raja now. That is, 1023 plus 125 is less than 1022 plus 128. Example 3. Which is greater, 113 minus 25 or 112 minus 24? Imagine a situation. Raja had 113 marbles and lost 25 of them. He has 113 minus 25 marbles. Joy had 112 marbles and lost 24 today. He has 112 minus 24 marbles. Who has more marbles left with them? Raja had 1 marble more than Joy. But he also lost 1 marble more than Joy did. Therefore, they have an equal number of marbles now. That is, 113 minus 25 is equal to 112 minus 24. The explanation for example 2 can be seen on the right side of the page, which is explained with the help of numbers. Likewise, for example 3, we can find the number of marbles Raja and Joy have. That has been explained here on the right side of the page. Page number 26. Use greater than or less than or equal to in each of the following expressions to compare them. Can you do it without complicated calculations? Explain your thinking in each case. A. 245 plus 289 dash 246 plus 285. B. 273 minus 145 dash 272 minus 144. C. 364 plus 587 dash 363 plus 589. D. 124 plus 245 dash 129 plus 245. E. 213 minus 77 dash 214 minus 76. 2.2 Reading and evaluating complex expressions. Sometimes, when an expression is not accompanied by a context, there can be more than one way of evaluating its value. In such cases, we need some tools and rules to specify how exactly the expression has to be evaluated. To give an example with language, we can observe from the following sentences. A. Sentence. Shalini sat next to a friend with toys. Meaning, the friend has toys and Shalini sat next to her. B. Sentence. Shalini sat next to a friend with toys. Meaning, Shalini has the toys and she sat with them next to her friend. Here, we find two pictures where Shalini is sitting with the toys and her friend. This sentence, without the punctuation, could have been interpreted in two different ways. The appropriate use of a comma specifies how the sentence has to be understood. Let us observe an expression that can be evaluated in more than one way. Example 4. Malesh bought 30 marbles to the playground. Arun bought 5 bags of marbles with 4 marbles in each bag. How many marbles did Malesh and Arun bring to the playground? Malesh summarized this by writing the mathematical expression 30 plus 5 into 4. Page number 27. Without knowing the context behind this expression, Purna found the value of this expression to be 140. He added 30 and 5 first to get 35 and then multiplied 35 by 4 to get 140. Malesh found the value of this expression to be 50. He multiplied 5 and 4 first to get 20 and then added 20 to 30 to get 50. In this case, Malesh is right. But why did Purna get it wrong? Just observing the expression 30 plus 5 into 4, it is not clear whether we should do the addition first or multiplication. Just as punctuation marks are used to resolve confusion in language, brackets and the notion of terms are used in mathematics to resolve confusions in evaluating expressions. Brackets in expressions. In the expression to find the number of marbles 30 plus 5 into 4, we had to first multiply 5 and 4 and then add this product to 30. This order of operations is clarified by the use of brackets as follows: 30 plus within brackets 5 into 4. When evaluating an expression having brackets, we need to first find the values of the expressions inside the brackets before performing other operations. So, in the above expression, we first find the value of 5 into 4 and then do the addition. Thus, this expression describes the number of marbles. 30 plus within brackets 5 into 4, that is equal to 30 plus 20, that is equal to 50. Example 5. Irfan bought a pack of biscuits for 15 rupees and a packet of tur dal for 56 rupees. He gave the shopkeeper 100 rupees. Write an expression that can help us calculate the change Irfan will get back from the shopkeeper. Irfan spent 15 rupees on a biscuit packet and 56 rupees on tur dal. So, the total cost in rupees is 15 plus 56. He gave 100 rupees to the shopkeeper. So, he should get back 100 minus the total cost. Can we write that expression as 100 minus 15 plus 56? Can we first subtract 15 from 100 and then add 56 to the result? We will get 141. It is absurd that he gets more money than he paid the shopkeeper. We can use brackets in this case. 100 minus within brackets 15 plus 56. Evaluating the expression within the brackets first, we get 100 minus 71, which is 29. So, Irfan will get back 29 rupees. Page number 28. terms in expressions. Suppose we have the expression 30 plus 5 into 4 without any brackets. Does it have no meaning? When there are expressions having multiple operations and the order of operations is not specified by the brackets, we use the notion of terms to determine the order. Terms are the parts of an expression separated by a plus sign. For example, in 12 plus 7, the terms are 12 and 7 as marked here. 12 plus 7 is equal to 12 is encircled plus 7 is also encircled. We will keep marking each term of an expression as above. Note that this way of marking the terms is not a usual practice. This will be done until you become familiar with this concept. Now, what are the terms in 83 minus 14? We know that subtracting a number is the same as adding the inverse of the number. Recall that the inverse of a given number has the sign opposite to it. For example, the inverse of 14 is minus 14, and the inverse of minus 14 is 14. Thus, subtracting 14 from 83 is the same as adding minus 14 to 83. That is, 83 minus 14 is equal to 83 is encircled plus minus 14 is again encircled. Thus, the terms of the expression 83 minus 14 are 83 and minus 14. Check if replacing subtraction by addition in this way does not change the value of the expression by taking different examples. Can you explain why subtracting a number is the same as adding its inverse, using the token model of integers that we saw in the class 6 textbook of mathematics? All subtractions in an expression are converted to addition in this manner to identify the terms. Here are some more examples of expressions and their terms. Minus 18 minus 3 is equal to minus 18 encircled plus minus 3 encircled. 6 into 5 plus 3 is equal to 6 into 5 encircled plus 3 encircled separately. 2 minus 10 plus 4 into 6 is equal to encircled 2 plus encircled minus 10 plus encircled 4 into 6. Note that 6 into 5, 4 into 6 are single terms as they do not have any plus sign. In the following table, some expressions are given. Complete the table. Page number 29. Here we find a table having 3 different columns. First column represents expression. Second column here expresses the expression as the sum of its terms. And the third column represents terms. First one, 13 minus 2 plus 6 can be expressed as encircled 13 plus encircled minus 2 plus encircled 6. What are the terms here? 13, minus 2, 6. Likewise, we have the next expression 5 plus 6 into 3. Here, expression can be expressed as sum of its terms as encircled 5 plus encircled 6 into 3. You are supposed to write down the terms in the third column. And similarly, we need to complete the 3 more expressions given here. 4 plus 15 minus 9 can be expressed as sum of terms as we can encircle the 3 terms separately with a plus sign in between. Next expression 23 minus 2 into 4 plus 16 can be expressed as sum of the terms, and the terms are to be written in the third column. 28 plus 19 minus 8 can again be expressed as sum of its terms in 3 and circles with plus sign in between and terms in the third column. Now we will observe how terms are used to determine the order of operations to find the value of an expression. We will start with expressions having only additions, with all the subtractions suitably converted into additions. Does changing the order in which the terms are added give different values? Swapping and grouping. Let us consider a simple expression having only two terms. Example 6. Madhu is flying a drone from a terrace. The drone goes 6 meters up and then 4 meters down. Write an expression to show how high the final position of the drone is from the terrace. The drone is 6 minus 4 is equal to 2 meters above the terrace, writing it as sum of terms. 6 encircled plus minus 4 is again encircled is equal to encircled 2. Will the sum change if we swap the terms? Encircled minus 4 plus encircled 6 is equal to encircled 2. It doesn't in this case. We already know that swapping the terms does not change the sum when both the terms are positive numbers. Will this also hold when there are terms having negative numbers as well? Take some more expressions and check.
Page 30.
Can you explain why this is happening using the token model of integers that we observed in the class 6 textbook of mathematics? Thus, in an expression having two terms, swapping them does not change the value. Term 1 plus term 2 is equal to term 2 plus term 1. Now consider an expression having three terms, minus 7 within brackets plus 10 plus within brackets minus 11. Let us add these terms in the following two different orders. Minus 7 plus 10 are added first, and then minus 11 is added to the total. Adding the first two terms and then adding their sum to the third term. Minus 7 plus 10 plus minus 11 encircled. Adding the first two terms and then adding their sum to the first term. What do you see? The sums are the same in both cases. Again, we know that while adding positive numbers, grouping them in any of the above two ways gives the same sum. Will this also hold when there are terms having negative numbers as well? Take some more expressions and check. Can you explain why this is happening using the token model of the integers that we observed in class 6 textbook of mathematics? Thus, grouping the terms of an expression in either of the following ways gives the same value. Term 1 and term 2 added together to term 3 is equal to adding of term 2 and term 3 to term 1. Let us consider the expression minus 7 plus 10 plus minus 11 again. What happens when we change the order and add minus 7 and minus 11 first, and then add this sum to 10? Will we get the same sum as before? We observe that adding the terms of the expression minus 7 within brackets plus 10 plus within brackets minus 11 in any order gives the same sum of minus 8. Page number 31. Does adding the terms of an expression in any order give the same value? Take some more expressions and check. Consider expressions with more than 3 terms also. Can you explain why this is happening using the token model of integers that we observed in the class 6 textbook of mathematics? Thus, the addition of terms in any order gives the same value. Therefore, in an expression having only additions, it does not matter in what order the terms are added. They all give the same value. Now let us consider expressions having multiplication and division also, without the order of operations specified by the brackets. The values of such expressions are found by first evaluating the terms. Once all the terms are evaluated, they are added. For example, the expression 30 plus 5 into 4 is evaluated as follows. 30 plus 5 into 4 is equal to encircle 30 plus encircle 5 into 4 is equal to encircle 30 plus encircle 20 is equal to encircle 50. The expression 5 into within brackets 3 plus 2 plus 78 plus 3 is evaluated as follows. 5 into within brackets 3 plus 2 plus 78 plus 3 is equal to 5 into within brackets 3 plus 2 encircled plus 7 into 8 encircled plus encircle 3, where within brackets 3 plus 2 is first evaluated and this sum is multiplied by 5, that is equal to 25. This expression 7 into 8 is evaluated as 56. This simplifies to 25 plus 56 plus 3 is equal to 84. Manasa is adding a long list of numbers. It took her 5 minutes to add them all and she got the answer as 11,749. Then she realized that she had forgotten to include the fourth number, 9,055. Does she have to start all over again? In mathematics, we use the phrase commutative property of addition instead of saying swapping terms does not change the sum. Similarly, grouping does not change the sum is called the associative property of addition. Swapping the order of things in everyday life. Manasa is going outside to play. Her mother says, "Wear your hat and shoes." Which one should she wear first? She can wear her hat first and then her shoes. Or she can wear her shoes first and then a hat. Manasa will look exactly the same in both cases. Imagine a different situation. Manasa's mother says, "Wear your socks and shoes." On this page, you can see pictures of Manasa wearing shoes and hat. Page number 32. Now the order matters. She should wear socks and then shoes. If she wears shoes and then socks, Manasa will feel very uncomfortable and look very different. More expressions and their terms. Example 7. Amu, Charan, Madhu and John went to a hotel and ordered 4 dosas. Each dosa cost 23 rupees and they wished to thank the waiter by tipping 5 rupees. Write an expression describing the total cost. Cost of 4 dosas is equal to 4 multiplied by 23. Can the total amount with tip be written as 4 into 23 plus 5? Evaluating it we get 4 into 23 plus 5 is equal to 4 into 23 encircled plus 5 encircled is equal to 92 encircled plus 5 encircled, that is equal to 97 encircled. Thus, 4 into 23 plus 5 is a correct way of writing the expression. If the total number of friends goes up to 7 and the tip remains the same, how much will they have to pay? Write an expression for this situation and identify its terms. Example 8. Children in a class are playing. Fire in the mountain, run, run, run. Whenever the teacher calls out a number, students are supposed to arrange themselves in groups of that number. Whoever is not part of the announced group size is out. Ruby wanted to rest and sat on one side. The other 33 students were playing the game in the class. The teacher called out 5. Once children settled, Ruby wrote 6 into 5 plus 3, understood as 3 more than 6 into 5. Think and discuss why she wrote this. The expression written as the sum of terms is encircled 6 into 5 plus 3 encircled. On this page, you find a picture of children who have arranged themselves in group of 5 plus 3 children are left out separately. Page number 33. For each of the cases given here, write the expression and identify its terms. If the teacher had called out 4, Ruby would write dash. If the teacher had called out 7, Ruby would write dash. Write expressions like the above for your class size. Example 9. Raghu bought 100 kg of rice from the wholesale market and packed them into 2 kg packets. He already had 4 2 kg packets. Write an expression for the number of 2 kg packets of rice he has now and identify the terms. He had 4 packets. The number of new 2 kg packets of rice is 100 divided by 2, which we also write as 100 upon 2. The number of 2 kg packets he has now is 4 plus 100 upon 2. The terms are encircled 4 plus encircled 100 upon 2. Example 10. Kannan has to pay 432 rupees to a shopkeeper using coins of 1 rupee and 5 rupees and notes of 10 rupees, 20 rupees, 50 rupees and 100 rupees. How can he do it? There is more than one possibility. For example, 432 is equal to 4 into 100 plus 1 into 20 plus 1 into 10 plus 2 into 1, meaning 4 notes of 100 rupees, 1 note of 20 rupees, 1 note of 10 rupees and 2 notes of 1 rupee. 432 is equal to 8 into 50 plus 1 into 10 plus 4 into 5 plus 2 into 1, meaning 8 notes of 50 rupees, 1 note of 10 rupees, 4 notes of 5 rupees and 2 notes of 1 rupee. Identify the terms in the two expressions above. Can you think of some more ways of giving 432 rupees to someone? Example 11. Here are two pictures. Which of these two arrangements matches with the expressions 5 into 2 plus 3? Page number 34. Let us write this expression as a sum of terms. Encircled 5 into 2 plus 3 is equal to encircled 10 plus n circle 3 that is equal to n circle 13. This expression 5 into 2 plus 3 can be understood as 3 more than 5 into 2, which describes the arrangement on the left. What is the expression for the arrangement in the right, making use of the number of yellow and blue squares? Do you recall the use of brackets? We need to use brackets for this. 2 into within brackets 5 plus 3. Notice that this arrangement can also be described using 5 plus 3 plus 5 plus 3 or 5 into 2 plus 3 into 2. Figure it out. Question number 1. Find the values of the following expressions by writing the terms in each case. A. 28 minus 7 plus 8. B. 39 minus 2 into 6 plus 11. C. 40 minus 10 plus 10 plus 10. D. 48 minus 10 into 2 plus 16 divided by 2. E. 6 into 3 minus 4 into 8 into 5. Question number 2. Write a story or situation for each of the following expressions and find their values. A. 89 plus 21 minus 10. B. 5 into 12 minus 6. C. 4 into 9 plus 2 into 6. Question number 3. For each of the following situations, write the expression describing the situation. Identify its terms and find the value of the expression. A. Queen Alia gave 100 gold coins to Princess Elsa and 100 gold coins to Princess Anna last year. Princess Elsa used the coins to start a business and doubled her coins. Princess Anna bought jewelry and has only half of the coins left. Write an expression describing how many gold coins Princess Elsa and Princess Anna together have. B. A metro train ticket between two stations is of 40 rupees for an adult and rupees 20 for a child. What is the total cost of tickets? First part, for 4 adults and 3 children. Second part, for 2 groups having 3 adults each. Page number 35. C. Find the total height of the window by writing an expression describing the relationship among the measurements given in the picture. Here, on the right side of the page, we find a picture with a beautiful cat sitting in the window. We have total height mentioned here and the gap of 5 centimeters, grill of 2 centimeters and a border of 3 centimeters. Removing brackets. Let us find the value of this expression. 200 minus within brackets 40 plus 3. We first evaluate the expression inside the brackets to 43 and then subtract it from 200. But it is simpler to first subtract 40 from 200. 200 minus 40 is equal to 160. And then subtract 3 from 160. 160 minus 3 is equal to 157. What we did here was 200 minus 40 minus 3. Notice that we did not do 200 minus 40 plus 3. So, 200 minus within brackets 40 plus 3 is equal to 200 minus 40 minus 3. Example 12. We also saw this earlier in the case of Irfan purchasing a biscuit packet 15 rupees and a tur dal packet 56 rupees. When he paid 100 rupees, the change he gets in rupees is 100 minus within brackets 15 plus 56 is equal to 29. The change could also have been calculated as follows. A. First subtract the cost of the biscuit packet 15 from 100, that is 100 minus 15 is equal to 85. This is the amount the shopkeeper owes Irfan if he had purchased only the biscuits. As he has purchased tur dal also, its cost is taken from this remaining amount of 85. B. So, to find the change, we need to subtract the cost of tur dal from 85. 85 minus 56 is equal to 29. What we have done here is 100 minus 15 minus 56. So, 100 minus within brackets 15 plus 56 is equal to 100 minus 15 minus 56. Notice how upon removing the brackets preceded by a negative sign, the signs of the terms inside the brackets change. Page number 36. Observe the signs of 40 and 3 in the first example and that of 15 and 56 in the second. Example 13. Consider the expression 500 minus within brackets 250 minus 100. Is it possible to write this expression without the brackets? To evaluate this expression, we need to subtract 250 minus 100, that is equal to 150 from 500. 500 minus within brackets 250 minus 100 is equal to 500 minus 150, that is equal to 350. If we were to directly subtract 250 from 500, then we would have subtracted 100 more than what we needed to. So, we should add back that 100 to 500 minus 250 to make the expression take the same value as 500 minus within brackets 250 minus 100. This sequence of operations is 500 minus 250 plus 100. Thus, 500 minus within brackets 250 minus 100 is equal to 500 minus 250 plus 100. Check that 500 minus within brackets 250 minus 100 is not equal to 500 minus 250 minus 100. Notice again that when the brackets preceded by a negative sign are removed, the signs of the terms inside the brackets change. In this case, the sign of 250 and minus 100 change to minus 250 and 100. Example 14. Hira has a rare coin collection. She has 28 coins in one bag and 35 coins in another. She gives her friend 10 coins from the second bag. Write an expression for the number of coins left with Hira. This can be expressed by 28 plus within brackets 35 minus 10. We know that this is the same as 28 plus within brackets 35 plus within brackets minus 10. Since the terms can be added in any order, this expression can simply be written as 28 plus 35 plus within brackets minus 10 or 28 plus 35 minus 10. Thus, 28 plus within brackets 35 minus 10 is equal to 28 plus 35 minus 10, that is equal to 53. When the brackets are not preceded by a negative sign, the terms within them do not change their signs upon removing the brackets. Notice the sum of the terms 35 and minus 10 in the above expression. Rather than simply remembering rules for when to change the sign and when not to, you can figure it out for yourself by thinking about the meanings of the expressions. Tinker the terms 1. What happens to the value of an expression if we increase or decrease the value of one of its terms? Some expressions are given in the following 3 columns. In each column, one or more terms are changed from the first expression. Go through the example in the first column and fill the blanks, doing as little computation as possible. Page number 37. We have 3 columns here. In the first column, we have encircled 53 plus encircled minus 16 is equal to encircled 37. In the column below, encircled 54 plus encircled minus 16 is equal to encircled 38. 54 is 1 more than 53, so the value will be 1 more than 37. Encircle 53 plus encircle minus 15 is equal to blank. Is minus 15 1 more or 1 less than minus 16? Find out. In the second column, we have encircle 53 plus encircle minus 16 is equal to encircle 37. Encircle 52 plus encircle minus 16 is equal to blank. 52 is 1 less than 53, so the value will be 1 less than 37. Encircle 53 plus encircle minus 17 is equal to blank. Is minus 17 1 more than or 1 less than minus 16? In the third column, we have encircle minus 87 plus encircle minus 16 is equal to a blank. Then minus 88 encircled plus minus 15 encircled is equal to blank. Minus 86 encircled plus minus 18 encircled is equal to blank. Minus 97 encircled plus minus 26 encircled is equal to blank. Figure it out. Question number 1. Fill in the blanks with numbers and boxes with operation signs such that the expressions on both sides are equal. A. 24 plus within bracket 6 minus 4 is equal to 24 plus 6 box dash. B. 38 plus within brackets there is a box is equal to 38 plus 9 minus 4. C. 24 minus within brackets 6 plus 4 is equal to 24 box 6 minus 4. D. 24 minus 6 minus 4 is equal to 24 minus 6 box dash. E. 27 minus within brackets 8 plus 3 is equal to 27 box 8 minus 3. F. 27 minus within brackets blank box blank close the bracket is equal to 27 minus 8 plus 3. Question number 2. Remove the brackets and write the expression having the same value. A. 14 plus within brackets 12 plus 10. B. 14 minus within brackets 12 plus 10. C. 14 plus within brackets 12 minus 10. D. 14 minus within brackets 12 minus 10. E. Minus 14 plus 12 minus 10. F. 14 minus within brackets minus 12 minus 10. Question number 3. Find the values of the following expressions. For each pair, first try to guess whether they have the same value. When are the two expressions equal? A. Within brackets 6 plus 10 minus 2 and 6 plus within brackets 10 minus 2. B. 16 minus within brackets 8 minus 3 and within brackets 16 minus 8 minus 3. C. 27 minus within brackets 18 plus 4 and 27 plus within brackets minus 18 minus 4. Question number 4. In each of the sets of expressions here, identify those that have the same value. Do not evaluate them, but rather use your understanding of terms. Page number 38. A. 319 plus 537, comma 319 minus 537, comma minus 537 plus 319, comma 537 minus 319. B. 87 plus 46 minus 109, comma 87 plus 46 minus 109, comma 87 plus 46 minus 109, comma 87 minus 46 plus 109, comma 87 minus within brackets 46 plus 109, comma within brackets 87 minus 46 plus 109. Question number 5. Add brackets at appropriate places in the expressions such that they lead to the values indicated. A. 34 minus 9 plus 12 is equal to 13. B. 56 minus 14 minus 8 is equal to 34. C. Minus 22 minus 12 plus 10 plus 22 is equal to minus 22. Question number 6. Using only reasoning of how terms change their values, fill the blanks to make the expressions on either side of the equality, that is equal to sign. A. 423 plus dash is equal to 419 plus dash. B. 207 minus 68 is equal to 210 minus dash. Question number 7. Using the numbers 2, 3 and 5 and the operators plus and minus and brackets as necessary, generate expressions to give as many different values as possible. For example, 2 minus 3 plus 5 is equal to 4 and 3 minus within brackets 5 minus 2 is equal to 0. Question number 8. Whenever Jasoda has to subtract 9 from the number, she subtracts 10 and adds 1 to it. For example, 36 minus 9 is equal to 26 plus 1. A. Do you think she always gets the correct answer? Why? B. Can you think of other similar strategies? Give some examples. Question number 9. Consider the two expressions A. 73 minus 14 plus 1. B. 73 minus 14 minus 1. For each of these expressions, identify the expressions from the following collection that are equal to it. A. 73 minus within brackets 14 plus 1. B. 73 minus within brackets 14 minus 1. C. 73 plus within brackets minus 14 plus 1. D. 73 plus within brackets minus 14 minus 1. Removing brackets part 2. Example 15. Lamu and Norbu went to a hotel. Each of them ordered a vegetable cutlet and a rasgulla. A vegetable cutlet cost 43 rupees and a rasgulla cost 24 rupees. Write an expression for the amount they will have to pay. As each of them had one vegetable cutlet and one rasgulla, each of their shares can be represented by 43 plus 24. Next question. What about the total amount they have to pay? Can it be described by the expression 2 into 43 plus 24? Page number 39. Writing it as sum of terms gives 2 into 43 encircled plus encircle 24. This expression means 24 more than 2 into 43, but we want an expression which means twice or double of 43 plus 24. We can make use of brackets to write such an expression. 2 into within brackets 43 plus 24. So, we can say that together they have to pay 2 multiplied by within brackets 43 plus 24. This is also the same as paying for 2 vegetable cutlets and 2 rasagullas. 2 into 43 plus 2 into 24. Therefore, 2 into within brackets 43 plus 24 is equal to 2 into 43 plus 2 into 24. On the right side, we can see the picture of a cutlet and a rasgulla, and you find for both of them 2 into 43 plus 24 is expressed here with a picture to understand the total cost. If another friend, Sangumu, joins them and orders the same items, what will be the expression for the total amount to be paid? Example 16. In the Republic Day parade, there are Boy Scouts and Girl Guides marching together. The Scouts march in 4 rows and 5 Scouts in each row. The Guides march in 3 rows and 5 Guides in each row. How many Scouts and Guides are marching in this parade? The number of Boy Scouts marching is 4 into 5. The number of Girl Guides marching is 3 into 5. The total number of Scouts and Guides will be 4 into 5 plus 3 into 5. This can also be found by first finding the total number of rows, that is 4 plus 3, and then multiplying their sum by the number of children in each row. Thus, the number of boys and girls can be found by within brackets 4 plus 3 into 5. Therefore, 4 into 5 plus 3 into 5 is equal to within brackets 4 plus 3 into 5. Computing these expressions, we get 4 into 5 plus 3 into 5 is equal to 4 into 5 encircled plus 3 into 5 encircled is equal to 20 encircled plus 15 encircled, that is equal to 35 encircled. Here we can find a picture displaying the Boy Scouts and Girls Guides in the order 3 by 5 and 4 by 5, which can be combined as 4 plus 3 within brackets multiplied by 5. Page number 40. Within brackets 4 plus 3 into 5 is equal to 7 into 5, that is equal to 35. 5 into 4 plus 3 is not equal to 5 into 4 plus 3. Can you explain why? Is 5 into within brackets 4 plus 3 equal to 5 into within brackets 3 plus 4? That is equal to within brackets 3 plus 4 into 5. The observations that we have made in the previous two examples can be seen in a general way as follows. Consider 10 into 98 plus 3 into 98. This means taking the sum of 10 times 98 and 3 times 98. 98 plus 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 98, that is 10 times, plus 98 plus 98 plus 98 3 times. So clearly this is the same as 10 plus 3, that is 13 times 98. Thus 10 into 98 plus 3 into 98 is equal to within brackets 10 plus 3 into 98. Writing this equality the other way, we get within brackets 10 plus 3 into 98 is equal to 10 into 98 plus 3 into 98. Swapping the numbers in the products above, this property can be seen in the following form. 98 into 10 plus 9 into 83 is equal to 98 within brackets 10 plus 3 and 98 within brackets 10 plus 3 is equal to 98 into 10 plus 98 into 3. Similarly, let us consider the expression 14 into 10 minus 6 into 10. This means subtracting 6 times 10 from 14 times 10. We can find here 10 is added 14 times. Clearly, this is 14 minus 6 is equal to 8 times 10. Thus, 14 into 10 minus 6 into 10 is equal to within brackets 14 minus 6 into 10, or within brackets 14 minus 6 into 10 is equal to 14 into 10 minus 6 into 10. This property can be nicely summed up as follows. The multiple of a sum or difference is the same as the sum or difference of the multiples. Tinker the terms too. Let us understand what happens when we change the numbers occurring in a product. Page number 41. Example 17. Given 53 into 18 is equal to 954. Find out 63 into 18. As 63 into 18 means 63 times 18, 63 into 18 can be written as 53 plus 10 within brackets into 18. That is equal to 15 into 18 plus 10 into 18. That is equal to 954 plus 180. That is equal to 1134. Example 18. Find an effective way of evaluating 97 into 25. 97 into 25 means 97 times 25. We can write it as 100 minus 3 into 25. We know that this is the same as the difference of 100 times 25 and 3 times 25. 97 into 25 is equal to 100 into 25 minus 3 into 25. Find this value. Use this method to find the following products. A. 95 into 8. B. 104 into 15. C. 49 into 50. Is this quicker than the multiplication procedure you use generally? Which other products might be quicker to find like the ones above? Figure it out. Fill in the blanks with numbers and boxes by signs so that the expression on both sides are equal. A. 3 into within brackets 6 plus 7 is equal to 3 into 6 plus 3 into 7. B. Within brackets 8 plus 3 into 4 is equal to 8 into 4 plus 3 into 4. C. 3 into within brackets 5 plus 8 is equal to 3 into 5 box 3 into dash. D. Within brackets 9 plus 2 into 4 is equal to 9 into 4 box 2 into dash. E. 3 into within brackets dash plus 4 is equal to 3 dash plus dash. F. Within brackets dash plus 6 into 4 is equal to 13 into 4 plus dash. G. 3 into within brackets dash plus dash is equal to 3 into 5 plus 3 into 2. H. Within brackets dash plus dash into dash is equal to 2 into 4 plus 3 into 4. I. 5 into within brackets 9 minus 2 is equal to 5 into 9 minus 5 into dash. J. Within brackets 5 minus 2 into 7 is equal to 5 into 7 minus 2 into dash. K. 5 into within brackets 8 minus 3 is equal to 5 into 8 box 5 into dash. L. Within brackets 8 minus 3 into 7 is equal to 8 into 7 box 3 into 7. Page number 42. M. 5 into within brackets 12 minus dash is equal to dash box 5 into dash. N. Within brackets 15 minus dash into 7 is equal to dash box 6 into 7. O. 5 into within brackets dash minus dash is equal to 5 into 9 minus 5 into 4. P. Within brackets dash minus dash into dash is equal to 17 into 7 minus 9 into 7. Question number 2. In the boxes below, fill less than, comma, greater than or equal to after analyzing the expressions on the left hand side and right hand side. Use reasoning and understanding of terms and brackets to figure this out and not by evaluating the expressions. A. Within brackets 8 minus 3 into 29 box within brackets 3 minus 8 into 29. B. 15 plus 9 into 18 box within brackets 15 plus 9 into 18. C. 23 into within brackets 17 minus 9 box 23 into 17 plus 23 into 9. D. Within brackets 34 minus 28 into 42 box 34 into 42 minus 28 into 42. Question number 3. Here is one way to make 14. 2 into within brackets 1 plus 6 is equal to 14. Are there other ways of getting 14? Fill them out below. A dash into within brackets dash plus dash is equal to 14. B dash into within brackets dash plus dash is equal to 14. C dash into within brackets dash plus dash is equal to 14. D dash into within brackets dash plus dash is equal to 14. 4. Find out the sum of the numbers given in each picture in at least two different ways. Describe how you solved it through expressions. Here we are given two pictures. In one, there's a combination of squares and circles. The squares, which are yellow in color, have 4 digits in them, and the circles have digit 8 in them. On the other side, we have another picture in which some circles are red in color, which have number 6 in them, and the other circles have number 5 in them. Figure it out. Question number 1. Read the situations given below. Write appropriate expressions for each of them and find their values. A. A district market in Begur operates on all 7 days of a week. Rahim supplies 9 kg of mangoes each day from his orchard, and Shyam supplies 11 kg of mangoes each day from his orchard to this market. Find the amount of mangoes supplied by them in a week to the local district market. Page number 43. B. Binu earns 20,000 rupees per month. She spends 5,000 rupees on rent, 5,000 rupees on food, and 2,000 rupees on other expenses every month. What is the amount Binu will save by the end of a year? C. During the daytime, a snail climbs 3 centimeters up a post, and during the night, while asleep, accidentally slips down by 2 centimeters. The post is 10 centimeters high, and a delicious treat is on its top. In how many days will the snail get the treat? Question number 2. Melvin reads a 2-page story every day except on Tuesdays and Saturdays. How many stories would he complete reading in 8 weeks? Which of the expressions below describes this scenario? A. 5 into 2 into 8. B. Within bracket 7 minus 2 into 8. C. 8 into 7. D. 7 into 2 into 8. E. 7 into 5 minus 2. F. Within bracket 7 plus 2 into 8. G. 7 into 8 minus 2 into 8. H. Within bracket 7 minus 5 into 8. Question number 3. Find different ways of evaluating the following expressions. A. 1 minus 2 plus 3, minus 4 plus 5, minus 6 plus 7, minus 8 plus 9, minus 10. B. 1 minus 1, plus 1 minus 1, plus 1 minus 1, plus 1 minus 1, plus 1 minus 1. Question number 4. Compare the following pairs of expressions using less than, comma, greater than, or equal to, or by reasoning. A. 49 minus 7 plus 8. Box. 49 minus 7 plus 8. B. 83 into 42 minus 18. Box. 83 into 40 minus 18. C. 145 minus 17 into 8. Box. 145 minus 17 into 6. D. 23 into 48 minus 35. Box. 23 into 48 minus 35 within brackets. E. within bracket 16 minus 11 into 12. Box minus 11 into 12 plus 16 into 12. F within bracket 76 minus 53 into 88. Box 88 into within brackets 53 minus 76. G 25 into within brackets 42 plus 16. Box 25 into within brackets 43 plus 15. H 36 into within brackets 28 minus 16. Box 35 into within brackets 27 minus 15. Page number 44. Question number 5. Identify which of the following expressions are equal to the given expressions without computation. You may rewrite the expressions using terms or removing brackets. There can be more than one expression which is equal to the given expression. A 83 minus 37 minus 12. First part 84 minus 38 minus 12. Second one 84 minus within brackets 37 plus 12. Third 83 minus 38 minus 13. Fourth minus 37 plus 83 minus 12. B 93 plus 37 into 44 plus 76. First part 37 plus 93 into 44 plus 76. Second part 93 plus 37 into 76 plus 44. Third part within brackets 93 plus 37 into within brackets 44 plus 76. Fourth part 37 into 44 plus 93 plus 76. Question number 5. Choose a number and create 10 different expressions having that value. Summary. First point, we have been reading and evaluating simple expressions for quite some time now. Here, we started by revising the meaning of some simple expressions and their values. Second point, we learned how to compare certain expressions through reasoning instead of bluntly evaluating them. Third point, to help read and evaluate complex expressions without confusion, we use terms and brackets. Fourth point, when an expression is written as a sum of terms, changing the order of the terms or grouping the terms does not change the value of the expression. This is because the commutative property of addition and the associative property of addition, respectively. Fifth point, to evaluate expressions within brackets. We saw that when we remove brackets preceded by a negative sign, the terms within the bracket change their sign. Sixth point, we also learned about the distributive property. Multiplying a number with an expression inside brackets is equal to the multiplying the number with each term in the bracket. Page number 45. Puzzle time. Expression engineer. Using 3 threes along with the 4 operations addition, subtraction, multiplication and division and brackets as needed, we can create several expressions. For example, within brackets 3 plus 3 divided by 3 is equal to 2, comma 3 plus 3 minus 3 is equal to 3, comma 3 into 3 plus 3 is equal to 12, and so on. Using 4 fours, create expressions to get all values from 1 to 20. Using the numbers 1, 2, 3, 4 and 5 exactly once in any order, get as many values as possible between -10 and +10. Using the numbers 0 to 9 exactly once in any order, make an expression with the value 100. What other similar interesting questions can you ask? Here we have a picture of children exploring and thinking about the puzzle. This is the end of chapter 2.
Ganit Prakash, you were just listening to this audiobook, Textbook of Mathematics for Grade 7. Narration Swarnlata Sharma. Sound recordist Ekant Vashisht. Production assistant Soumya Malik. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.